through the data set all the way to the end of the recording, and then you can simply move it back. So if there was anything that happened during the recording that you want to look at specifically, and perhaps maybe pull out of the data set, which we can do during an advanced with some advanced work, you can have that ability. Or if you have a tricky data set that you need to look at the middle part of the recording because you're not quite sure something might have happened, and it's giving you some funny readings, you can see that, and then that will help you to identify perhaps a little bit better what happened. Okay, so at this point now we have the data loaded into the BioSuite HRV program, and up here on the right hand side you'll see a drop down box, and it's currently labeled EKG right at the moment. And if we push on the left arrow, or the arrow here, it will give a drop down box that says EKG, signal, and HRT, which stands for heart rate. Now that will allow you to select whatever signal you have, because some people when they buy a BioSuite HRV don't use the EKG function. Some people do. Other people don't even purchase the EKG with their system. And so we wanted to be able to give you the most flexibility that we could. So I've selected EKG because that's what we used in this recording. And what we're going to do now, if you remember the little red bar that was over here before the data loaded, it's still here, and if you pay very close attention, it's right up here at the top of the black box. And what we need to do now is we need to tell the software the voltage threshold with which to select the R to R data time. In other words, we need to take all of that complex data that gives us the QRS-T waves, and we need to boil that down into just the HRV data, the heart rate variability data. And so in order to do that, we simply put the mouse over that scroll bar, left click and hold, and then drag the red bar downward, and now you can see, just as we got into the peaks, stuff starting to happen in the bottom black box. Now I'm going to drag this down to about 3 millivolts, and I'll explain why once we get there. So that should be close enough. And what we try to do with this, everyone always asks me why we have this function, and then more importantly, how does it work? The reason that we put this into the system is because if, for example, you have a child, children have a very high heart rate, and if you're doing a scan on them, they have a very high millivolt or electrical output. As we age, like a lot of other things, that output changes and decreases. So if you want to be able to do an HRV scan on a 10-year-old, and then after that do an HRV scan on an 80-year-old, you have to have a way to adjust the voltage threshold in order to tell the software where to look for the data. And that's what this does. Now, how do you use it? What I tell people or clients to do is to try to pick somewhere in the middle of these data peaks, and if you can find a major number, such as in this case it's at 3 millivolts, that's ideal. So depending upon where you are and how high the voltage peaks are, you may only be able to do like 1.5 or 1.3 millivolts, somewhere in there. You will know that you have done this correctly when you end up with a finished data set that looks very similar to the one down here at the bottom in the bottom black graph. And if you're not happy with, say you let go of it like I have and you need to move it down even farther, all you have to do now is simply just left click and hold again, drag it down even farther, and you can see there's very little change that's happening. So I know that no matter where I move it down here, we're not getting a whole lot of changes in the data, and so therefore that's another way to check yourself and make sure that what you are that the threshold level that you've selected is going to be accurate. Okay, so the next thing then that we need to do is just tell the computer to tell the program to perform the FFT, which is the fast Fourier transform. And that's the preferred method of dealing with HRV. So we push this button, and this brings up a pop-up window, and I'm just going to move it into the center so that you can see it a little bit better. You can maximize this if you want to, so that that's all you see. But what we have here now are three distinctive graphs, and you can, four distinctive graphs. You have the entire fast Fourier spectrum from 0 all the way up to 0.5 Hertz here at the top. Then you have the individual spectrums broken down in the three graphs at the bottom: hypothalamus, sympathetic, and parasympathetic output. And this is where we where the rubber meets the road, so to speak. This is where we can actually see all of the data that we've pulled out. Now, let's say this is really small, and you want to see something particular like the parasympathetic output. All you have to do is just put your mouse over top of it, double click on it, and now it's larger, and now you can see the whole thing. Okay? If you want to shrink that back down, just simply double click again, and now you're back to the whole picture. And you can do that for any of the graphs that are displayed here, even the large graph. You can see the whole thing. So it's quite flexible, and it's very, very easy to use. Now, for those of you who are doing research or who are into numbers and you want to see specific information, or if you have information for us here at HRV Enterprises that you want us to analyze, and without sending the whole data set, the numbers for the output of each section are listed over here on the right in the table. So you have hypothalamus, which is the very low frequency, sympathetic, which is the low frequency, and parasympathetic, which is the high frequency. You have the average amplitude, that's the average height of the data peaks here. Peak amplitude, which is the top peak in that data set. So let me bring up sympathetic here. So that would be this frequency right here. That's the top peak amplitude there at 70.652. And then peak frequency, which is 0.143, which you can see is going to be about right there. And that lists that for each branch of the autonomic nervous system. Now, that's great. That information can be placed in your chart if you wish. You can write it down on the table. You can do a print screen function if you wish to, but it's not very easy to read. And recognizing that, we wanted to build in a report form, a much improved report form, for you and your patients. So in order to do that, we just simply come down to the box in the lower right hand corner that says report, and we select that, and here is the report. And I'm going to resize this just so that you can see it better, and I'll expand this up. And if you have a screen that's too small to get it all on, you can simply use the scroll bar here on the left. If you have a larger laptop or a larger screen, it will all display. But let's walk you through now on the report function, and I'm going to move this to the center of the screen here so that you can see it, and resize it again. So we have several things displayed here. Some will look familiar and some won't. And so let me walk you through what we have. First of all, up here in the top of the report sheet is the patient name function. Now, this is part of the new HIPAA rules where the person that's actually doing the scanning actually needs to put in the data. And so, in other words, you actually are going to have to type in the patient data. And to do that, you just simply put the cursor up there, scroll over, and then we're just going to type in this. We labeled this one untitled, and so that's going to be our patient name. Now, you don't need to worry about the date, because here is the date that this was generated. I'm recording this a little bit after the several months actually after the initial recording, and then here's the time that it was done, so 3:09 and 11 p.m. So